Welcome to How GreenOps Builds More Resilient Platforms. My name is Johannes Rudolph, and with this PlatformCon talk, I want to give you a few ideas of how you can implement GreenOps in your own platform engineering initiative, why it matters, what benefits you can take away from it. And I'll also want to give you a few practical examples of how we implemented that here at MeshCloud in our own platform as a source of inspiration for starting your own journey, maybe. Okay, what is GreenOps? Well, it's yet another one of these ops things, right? We've had DevOps and DevSecOps and FinOps, and now there's yet another thing to take care of for our development teams. And obviously, framing it that way is not a very attractive proposition, right? We don't want to shift left everything onto our development teams. We want them to be able to just shift down a few concerns into a platform and have that being taken care of to reduce their cognitive load and keep them fast and efficient. And this is the perspective I want to talk to you about today and share a few examples of really how GreenOps techniques also help you build a more resilient platform and show you that most of the time, the things we have to do to reduce our impact on the environment also align very well with other goals that we might already have in our platform engineering initiative. Okay, to understand GreenOps, we have to talk about the cloud. And in platform engineering, we think about the cloud as an operating model most of the time. So we sit in our basement or in our living room, home office, and run kubectl apply, Terraform apply, and spin up infrastructure at the other end of the world. That's the power of automation, and it's pretty incredible if you think about it, how powerful that tool is that we have available to, at any instant, get the infrastructure that we need to run computations at massive scale, and that's very powerful and credible, really. But the key problem with that is that with great power comes great responsibility, right? The cloud is not just an operating model that we like to think about. It's not just these Legos that we give to our developers. It's not just these infrastructure bits and pieces and that reusable things that we give to them and they can get that via an API. But at the end of the day, the cloud runs in a place because the cloud is at the end of the day just a bunch of Linux servers, as an oversimplification, right? And these Linux servers, most of the time live in a proper data center. And this is how your cloud provider would like you to believe that data center looks like. This is from the marketing website of GCP. This is showing Europe West 1 in Belgium. We have green lush grass and we have solar panels down there, and it's all very clean and green and nice, isn't it? Well, that's a theory, right? In real life that I experience, living and working in Germany near Frankfurt, data centers look like this. This is a picture I took riding my bike home from the office recently, where there's above one of the data center parks that I drive by, and we have a lot of them in Frankfurt, a lot of data center parks. You see, big black smoke clouds hanging in the air. What is that? Well, that's the backup power, generation, which is like big ship diesel engines essentially being tested every month. You have to do that to make sure they still function in case you really, really need them. Obviously that burns fuel and that causes emissions, and that might not look very nice. So how do we quantify and measure the emissions of a data center to better understand its impact on the environment? The standard way to do this is to use something called the greenhouse gas protocol, which essentially quantifies all of the emissions and then calculates that as like CO2 equivalents. And the way to do that is to look at three different scopes. So scope one is all of the emissions caused directly by a facility, so the data center. So the ship diesel engine emissions, they would account into that bucket. The second is all of the emissions that are caused somewhere else, but indirectly caused by, for example, consuming energy from the public grid. So the power plants, for example, that generate the electricity that is consumed in the data center, those emissions, we need them as well. And scope three is everything that went into the supply chain for the data center. Sometimes we call that also like the embodied carbon, essentially all of the footprint for producing the CPUs and servers, essentially, in our example. And then to calculate our own footprint of running workloads in the cloud, we can take the emissions of that entire data center, break it down across all of the workloads that run into there, and then we have, the share essentially of emissions that our own workload is accountable for. How does that look like in Frankfurt, or for running a workload in a data center in Frankfurt? Well, the main source of emissions really for running something on the cloud is the energy consumption. And the energy production here around Frankfurt happens to be mostly coal and gas. Despite Germany having a lot of renewables, right, you can't transport the energy everywhere that it's needed for consumption. So locally here in Frankfurt, we have a lot of coal and gas power plants. And they are real world things. I look at them in the region that I live. Like, this is Staudinger. It's a couple 100 meters high. You can see it from all around the areas. Or if you ever travel through Frankfurt main station by train, this is Frankfurt West, like a coal power plant in the middle of the city. So this is real impact that matters to me personally, because it happens in the environment that I live. So let's talk about resilience. How can we do GreenOps while simultaneously improving the resilience of our platform and our workloads? I want to talk about 3 GreenOps techniques today. And these are like really core techniques. The first is thinking about the location that you run your workloads in and making conscious choices about that. The second is being flexible about when to run your workloads and building your applications in a way that you can take advantage of that. And the third is to think about your platform architecture and how that might enable you to achieve these goals more easily or more effectively at scale for your organization. So I also promised I want to talk about practical examples. So I'll use our own GreenOps journey here at MeshCloud as an anecdote, essentially. So in 2022, we made the decision to leave AWS, which was our cloud provider at the time. We ran our platform because our credits were running out, like we're a startup, and we're like, hey, we need to make a conscious choice of where we want to run. And we also happened to run all of our workloads in Frankfurt, because at the time we didn't really think about it. The company is headquartered in Frankfurt, so we just ran the workload there. It's kind of like an easy choice, but it was not a conscious one. And then in 2022, when we essentially decided to move our internal platform, which was based on Kubernetes at the time, we had to figure out, where do we want to run this? And we looked at GCP because we liked, GKE a lot. And then we figured out, hey, there's actually huge differences between the climate friendliness, if you will, of different regions. And interestingly, I didn't know that at the time, there's also a huge pricing difference. It turns out that Belgium, which is the region that we ended up choosing, is 15% cheaper than Frankfurt. And that's quite interesting. And the prices vary by instance type, so what you look at. For example, spot instances are very cheap in Finland. We run our CI/CD workloads there. We moved that over there because they are very cheap. It's also very climate friendly. And that was very beneficial to us. What enabled this is that our platform team negotiated essentially with our ISO certification and our security officer to figure out that we can run our workloads pretty much anywhere within the European Union. So we had a lot of flexibility about this. And if you think about it that way and you build this like region flexibility into your platform, you might also achieve, some resilience goal when it comes to like geopolitics, for example, that you are able to and have built your platform in a way that you can shift things around if you have to, because the regulatory environment changes, for example. The second technique is being conscious about when you run your workloads, right? And separating your platform. I mean, this is a core like cloud native engineering technique. We don't want to build applications in a way that everything has to run all of the time, right? We want to scale things down to zero. And especially for like data and compute intensive things, this can matter a lot when it comes to GreenOps. So what you can see here is for Germany, a typical day in early April, and how the energy production in the public grid looks like. And you can very clearly see like when noon is every day, that's like the big yellow solar peak, right? This is when you have the most solar power available. And typically that allows us to turn down the coal and gas power plants a little. And then sometimes when there's also a lot of wind, we can like turn them down like for longer stretches of time. And all of these times are good times to consume energy, because the energy that you get at the time is a lot more clean. And also prices are correlated with that. The energy is more cheap at the time, which your cloud provider may or may not allow you to take advantage of. But that's another story. So if you build your applications in a way and your platform in a way that allows your developers to easily build applications to take advantage of the scheduling, you can literally reduce your climate impact by changing one line in your cron tab file, right? Just to oversimplify things. We did that for some of our data pipelines and things, and we moved them to run at the middle of the day. Really easy change, and it had a measurable impact. So that was really a quick win for us. Another technique is, and this is like really important, is really to be conscious about your platform architecture and how your platform architecture enables you to build better applications faster, and in a central platform team drive some optimization initiatives that you would otherwise not be able to decentrally implement in every individual application team. For us, it meant our application teams are too small to take care of things like testing and benchmarking the optimal instance types, for example, to run the workloads on, or configuring autoscaling for their own clusters. This is a difficult topic to get right. Our central platform team does have the SREs and the skills to do that, so that made a lot of sense for us with our Kubernetes-based platform. Another thing, and this is an angle I've already talked quickly about, is that by having our platform abstraction, and we like to think about our Kubernetes-based platform as like a container ship, really. It's visually quite appealing, is that allows us to also be resilient against vendor risk, essentially. We can very easily take that ship and move it from AWS to GCP, as we've done in the past, or move it somewhere else in the future, or on-prem if we really want to. And this is because this platform abstraction really buys us that flexibility. And this is also quite interesting because it allows us to have that flexibility while also having the opportunity to drive optimizations like better instance types from a central team. I forgot to mention, why would you want to choose better instance types? Well, new hardware generations become available every other year, pretty much, and they allow you to run more workloads for the same energy consumption, and sometimes that also turns out to be cheaper. So that's something you want to look into, probably. Bonus tip. I really underestimated this. So when we started our GreenOps journey, we did one thing in the beginning, and that was building the emissions data, the footprint data that we get from GCP, building that into our developer portal so developers could see that. And the place where we built that into was right next to the cost data. And whereas the cost data and the FinOps reporting essentially did not spark any emotions with our engineers, pretty much, the footprint data, the carbon footprint data did. And we suddenly had a lot of discussions within the team, like where could we save some, infrastructure, and where could we move some things around and schedule things differently to save. And that was quite surprising. I can, on a personal level, understand that pretty well, right? As an engineer, maybe your individual motivation might be more aligned with like saving the climate than saving your employer's money. As a CTO, right, that's also responsible for the IT budget. Obviously, I would like them to take care of the budget as well. But I can, rest assured they do that while looking at, the climate, because most of the time, saving emissions by, reducing the amount of workload that you run or running it more intelligently with like spot instances is so well aligned with saving costs that it's literally the same thing to me, and I'm very happy that my engineers look into it more actively that way. So make it transparent. It's a bonus tip. All right. I hope that gave you a few ideas and inspiration for how you can start your own GreenOps journey with your platform engineering initiative. I would love to stay engaged on the topic with you, with the community, and with Q&A. So feel free to engage there. Thanks so much for listening, and hope to talk to you soon. Thank you, and goodbye.